In September 2024, a Freedom of Information Act request was filed with NASA that set off a chain of revelations, denials, appeals, and ultimately, an admission that has raised questions about the agency's transparency. The request, filed by the Black Vault, asked for records of congressional briefings on the James Webb Space Telescope between 2021 and 2024. It specifically sought classified and unclassified materials relating to congressional updates about the James Webb Telescope discoveries. What at first seemed like a simple inquiry quickly escalated into a much larger controversy about secrecy, internal communications, and whether NASA has been caught misleading the public. The reason the request was filed in the first place is important to understand. By mid-September of 2024, speculation had already begun circulating online, spurred by viral videos and social media posts. These posts claimed that the James Webb Space Telescope had detected something extraordinary, a mysterious object moving toward Earth. Rumors suggested that NASA had already briefed members of Congress about the discovery in closed sessions, and that the information was being withheld from the public. The speculation gained further traction when journalist Matt Laszlo, as part of his Ask a Poll project, asked Representative Andre Carson directly whether he had attended classified James Webb Telescope briefings. Carson had previously chaired a congressional hearing on unidentified aerial phenomena, making him a key figure in the discussion. His refusal to respond was taken by many as confirmation that something was indeed being hidden. NASA's first response to the Freedom of Information Act request was categorical. In an October 9, 2024 letter, the agency claimed that no records existed. The searches, they said, had been conducted within the offices of Legislative and Intergovernmental Affairs and the Science Mission Directorate, and no documents matching the request were found. On the surface, this seemed to put the matter to rest. If no records existed, then there was nothing more to discuss. Yet those following the issue closely were not convinced, pointing out that NASA had publicly testified about the telescope's discoveries in November of 2022. Such testimony would almost certainly have required preparatory materials and internal briefings. An appeal was quickly filed, challenging the adequacy of NASA's search. The appeal argued that the denial overlooked obvious records, such as preparatory documents for NASA's November 16, 2022 hearing before the House Subcommittee on Space and Aeronautics. That session, titled Unfolding the Universe, Initial Science Results from the James Webb Telescope, featured testimony from leading figures in the field, including Dr. Mark Clampin, Dr. Stephen Kinkelstein, and Dr. Natalie Batalha. It was implausible, critics argued, that such a significant event would have occurred without any supporting internal documentation. By December of 2024, the Office of the General Counsel sided with the appeal. They admitted that responsive records did in fact exist, and that NASA's initial claim had been inaccurate. The case was remanded for further processing. This reversal, in itself, was telling. An agency that had initially insisted no documents existed now conceded that they did, raising questions about whether the original denial had been an honest mistake or a deliberate attempt to shield information from public scrutiny. The next development came on August 29, 2025, when NASA released 24 pages of documents under the new case number 2500860 FHQ. These documents were briefing slides prepared for the November 15, 2022 prep session ahead of the public hearing. The slides revealed the structure of NASA's internal preparations, with headings such as themes, messages, questions to think about, and further questions to think about. Yet nearly all of the actual content was withheld under the Freedom of Information Act Exemption B5, which protects deliberative process communications. The use of Exemption B5 has been a source of contention in transparency debates for years. The exemption does not signify that the information is classified. Rather, it protects pre-decisional, deliberative discussions within agencies. NASA argued that releasing the withheld material would undermine their ability to engage in candid internal conversations. They stated that disclosure would make employees cautious about what they say in preparatory discussions, potentially harming the agency's effectiveness. However, what makes this case stand out is the context. The withheld slides were not for a classified session, but for a public hearing. NASA officials had already openly testified about the James Webb Telescope's results, and video of the hearing remains available to the public. Why, then, should preparatory notes and suggested talking points tied to a public event be treated as sensitive? Under the Freedom of Information Act request law, Exemption B5 allows, but does not require withholding. Agencies can release deliberative material if they determine that disclosure would not cause harm. In this case, NASA chose near-total redactions, even though the subject matter had already been aired publicly. This inconsistency is what has fueled accusations that NASA was caught in a lie. Their initial no records response was overturned by their own legal office, showing that documents did exist all along. When the documents were finally released, their content was so heavily redacted that little could be learned. In essence, the public was shown an empty framework of what NASA had prepared, but was denied access to the substance. For those who believe NASA is hiding groundbreaking discoveries, the sequence of denial, reversal, and redaction looks suspicious. The controversy also highlights the tension between public right to know and government control of information. The James Webb Space Telescope is not a classified military asset, but a publicly funded scientific project. Its discoveries belong to humanity, not to a select few. For NASA to withhold information related to a public hearing undermines trust and invites speculation that something larger is at play. Some argue that if the James Webb Telescope had detected something extraordinary, such as evidence of life, a mysterious structure, or an approaching object, the agency might attempt to control the narrative before releasing details. The deliberate process exemption provides a convenient mechanism for doing so. Speculation has only deepened in the wake of these developments. The original rumors in 2024 suggested that the James Webb Telescope had detected a mysterious object moving toward Earth. The secrecy surrounding the congressional briefings, combined with NASA's refusal to release internal notes, has kept those rumors alive. Representative Carson's silence when asked about classified James Webb Telescope briefings has also fueled the sense that something significant is being withheld. While no direct evidence has been released to confirm the existence of such an object, the sequence of NASA's responses has given critics plenty of reason to doubt the agency's transparency. At the heart of the controversy lies a simple question. If the documents related only to a public hearing, why did NASA go to such lengths to withhold them? Their justification, that releasing the material would chill internal discussions, rings hollow when compared to the broader public interest. The Freedom of Information Act request was designed to give citizens insight into government operations, especially when public resources and public trust are at stake. By withholding nearly everything, NASA has effectively provided the opposite of transparency. The implications of this case go far beyond a single telescope or hearing. If NASA is willing to deny records that clearly exist and later redact nearly all useful information under a discretionary exemption, it raises concerns about how the agency handles information more broadly. For the public, the James Webb Space Telescope represents one of the most exciting scientific tools of the modern age. Its ability to peer deeper into the cosmos than ever before has already reshaped our understanding of galaxies, exoplanets, and the earliest moments of the universe. The suggestion that such a telescope may have discovered something extraordinary, only for the information to be buried in layers of bureaucratic denial and redaction, cuts to the core of public trust. The Apollo 17 Triangle. The Apollo missions remain some of the most scrutinized events in human history, with millions of images and hours of footage available to the public. Yet, despite this extensive record, there are still certain photographs that stand out as particularly mysterious. One such image comes from Apollo 17, the final mission to the Moon, which took place in December of 1972. At first glance, the photograph shows the desolate yet beautiful lunar landscape, with its rolling hills, soft grey dust, and black sky. However, a closer inspection of the high-definition version of this image reveals something far more intriguing. A glowing triangular formation hovering in the right-hand corner of the frame. Strangely, the high-definition version of this image has proven difficult to locate. NASA's official archives contain a compressed, lower-resolution version where the triangle cannot be clearly seen. This has sparked widespread speculation as to why the higher-quality version is not more readily available. Critics argue that this omission may not be accidental, but rather a deliberate attempt to obscure the details of whatever object appears in the frame. For those who have analyzed the original high-definition copy, the triangular object is striking. It emits a faint glow, with 3 distinct points of light forming a near-perfect triangle, a shape long associated with some of the most mysterious and unexplained craft in modern UFO reports. The Black Triangle UFO has become one of the most iconic shapes in the study of unidentified aerial phenomena. Silent, enormous, and often described as moving with eerie precision, these craft are regularly spotted above military installations, nuclear sites, and areas of heightened strategic interest. Witnesses consistently report that the craft appears to hover effortlessly before vanishing at incredible speeds. What makes this Apollo 17 image so fascinating is the implication that these objects are not confined to Earth's skies, but have been observed near the Moon as well. If the glowing triangle captured in this photograph is indeed one of these mysterious craft, it raises profound questions. Why would such an object be present during one of humanity's most historic journeys? Was it simply observing the mission, or could it have played a more direct role in monitoring human activity beyond Earth? The fact that it appears in proximity to astronauts exploring the lunar surface suggests that these craft may have a particular interest in our ventures into space. Skeptics often argue that anomalies in space photographs can be explained as lens flares, reflections, or processing errors. Yet the triangular object in this image does not fit neatly into those categories. Its geometric shape is too precise, and the distribution of its glowing points suggests deliberate design rather than random artifacting. Natural phenomena rarely produce such symmetry, especially in the harsh lighting conditions of the lunar surface. For many researchers, this level of structure implies intent, suggesting the presence of technology far beyond our own capabilities. Equally puzzling is the silence surrounding the object. Official mission transcripts and astronaut accounts make no mention of a glowing triangular formation in the sky above the lunar hills. This could mean that it was not visible to the naked eye, but was captured by the camera's sensors, or that any references to it were omitted from public records. Either possibility only deepens the mystery. The idea that triangular craft might operate near the Moon is not without precedent. Numerous accounts over the years have suggested that large, silent vehicles patrol both low Earth orbit and cislunar space. Some have speculated that these craft could belong to advanced extraterrestrial civilizations monitoring our progress, while others argue they could be part of secretive human programs hidden from the public eye. Whichever theory one subscribes to, the Apollo 17 photograph provides a rare piece of visual evidence to fuel the debate. The implications of such an object being real are staggering. If these craft are extraterrestrial in origin, their presence during Apollo 17 would suggest a long-standing awareness of, and perhaps interest in, human spaceflight. If they are human-made, it would indicate that technology far beyond conventional propulsion systems has been secretly developed and deployed, raising questions about who controls it and why it has remained hidden. What makes this case particularly compelling is the combination of visual evidence, historical context, and the mysterious handling of the photograph itself. The decision to release only a lower resolution version to the public, while the high-definition image reveals something extraordinary, suggests that there is more to the story than officials are willing to admit. The glowing triangle is not just another light anomaly, it fits too closely with decades of eyewitness testimony describing black triangle UFOs. For those studying the phenomenon, this Apollo 17 photograph stands as a reminder that mysteries persist even within humanity's proudest achievements. While astronauts planted flags and collected lunar rocks, something else may have been watching from the shadows of space. Whether it was a silent guardian, a curious observer, or something altogether unknown, its presence near the Moon challenges our understanding of what took place during those historic missions. Scientists think they have detected radio emissions from an exoplanet. The search for exoplanets has become one of the most exciting and rapidly advancing fields in astronomy. Exoplanets, planets that orbit stars beyond our own sun, represent the tantalizing possibility of discovering other worlds that might resemble Earth or even host life. For decades, astronomers have been devising new methods to detect these distant planets, from measuring the slight dimming of starlight as a planet passes in front of its star, to calculating the wobble of stars caused by the gravitational tug of orbiting bodies. Now, for the first time, scientists believe they may have detected an exoplanet not through light or gravitational effects, but through radio emissions. This discovery, if confirmed, represents a groundbreaking shift in exoplanet research and provides new avenues for studying the fundamental nature of these distant worlds. The research centers around the Tau Bor-Tees system, a star system already known to host at least one giant exoplanet, Tau Bor-Tees b. Using the low-frequency array in the Netherlands, astronomers detected faint but notable radio emissions that appear to be consistent with predictions for an exoplanet with a strong magnetic field. These findings are being hailed as one of the first serious indications that we might be able to study exoplanets through their radio emissions, much as we have done with planets in our own solar system. To understand the significance of this work, it helps to recall that magnetic fields play a crucial role in shaping the environment of planets. Earth's magnetic field, for example, acts as a protective shield against the solar wind, a stream of charged particles from the sun that would otherwise strip away the atmosphere over time. Without its magnetic field, Earth might not be habitable today. Studying magnetic fields beyond our solar system has always been a challenge, but radio emissions offer a potential window into this unseen force. The team led by astronomer Jake Turner of Cornell University began their work by studying Jupiter, the gas giant in our own solar system. Jupiter emits powerful bursts of radio waves, particularly when its magnetic field interacts with its volcanic moon Io. These radio emissions can be detected from Earth, providing a clear example of how magnetic fields can generate measurable signals. By adjusting their data to simulate what Jupiter's emissions would look like if observed from many light-years away, the researchers created a template they could compare to exoplanetary systems. When they examined this area using the low-frequency array, they noticed a faint but distinct signal that closely matched what would be expected from a planet. Turner explained that the strength and polarization of the signal, when combined with theoretical models of the planet's magnetic field, fit neatly with the hypothesis that the emissions were originating from the planet itself. While they cannot yet be certain, the evidence is strong enough to suggest that this may be the first direct detection of an exoplanet through radio astronomy. The implications of this discovery are immense. If radio emissions can indeed be used to detect exoplanets, this adds an entirely new tool to the astronomer's toolkit. Currently, most exoplanet detections come from missions like NASA's Transiting Exoplanet Survey satellite, which has already discovered thousands of candidate exoplanets by observing the tiny dips in starlight caused when planets transit their stars. However, this method has limitations. It is biased toward larger planets close to their stars, and it requires the planet's orbit to be aligned in such a way that it crosses the star from our point of view. Radio astronomy, by contrast, could allow us to detect planets in a wider variety of conditions, including those with strong magnetic fields that might protect atmospheres and create habitable environments. The use of the low-frequency array was particularly critical in this study. This radio telescope is one of the most sensitive radio telescopes in the world, designed to scan vast swathes of the sky at low frequencies. It was able to pick up not only the signal from this area, but also other signals from nearby stars. This highlights another important point. Radio emissions are not always straightforward to interpret. Stars themselves can emit radio waves, as can other celestial phenomena. Distinguishing between planetary and stellar sources requires careful analysis, and this is why more data will be needed before scientists can be absolutely confident in their interpretation. Even so, the discovery has already generated enormous excitement within the scientific community. If confirmed, it represents a new era in exoplanet research, one that allows scientists to move beyond just counting planets and begin studying their deeper properties, such as magnetic fields, atmospheres, and internal structures. This will also help answer fundamental questions about how planets evolve and what makes some of them capable of supporting life. Another reason this discovery is so important is that it opens the door to studying exoplanetary space weather. Just as Earth's magnetic field protects it from solar storms, the magnetic fields of other planets could determine whether they retain their atmospheres and remain habitable over billions of years. By studying radio emissions, scientists can gain clues about how much energy a planet's magnetic field is interacting with from its star, how intense those interactions are, and whether the planet's environment is stable enough to sustain life. The discovery also highlights the importance of international collaboration and innovation in astronomy. The low-frequency array, with its thousands of antennas spread across Europe, represents one of the most ambitious efforts to explore the low-frequency universe. The fact that it was able to pick up these faint signals even while still in its pre-commissioning phase speaks to the potential of this technology. As it becomes fully operational and refined, its ability to uncover even more planetary radio emissions could revolutionize our understanding of distant worlds. Of course, there is still much work to be done. The signal from this area needs to be confirmed by independent observations, and researchers will need to ensure that there are no alternative explanations. Stars can sometimes produce emissions that mimic planetary signals, and the possibility of other cosmic sources must be carefully ruled out. However, even with these uncertainties, the discovery has already proven that the method is viable and that the future of exoplanet research will likely involve a significant radio astronomy component. In the broader context of humanity's search for life beyond Earth, this breakthrough could prove to be one of the most important steps yet. If we can study magnetic fields and atmospheres of exoplanets using radio emissions, we will be better equipped to identify which worlds might be habitable and which are unlikely to support life. Over time, this could guide future missions, helping us focus on the most promising candidates for detailed exploration. Scientists find 13 mysterious deep space flashes. Fast radio bursts are among the greatest puzzles in modern astronomy, and a recent discovery has only deepened both the mystery and the excitement surrounding them. These bursts are incredibly powerful, short-lived flashes of radio waves that seem to originate from distant regions of the cosmos. Despite years of research, their true origin remains unknown. What sets them apart is the extraordinary energy they release in a fraction of a second, rivaling the total output of entire galaxies during that moment. Theories abound, ranging from natural astrophysical phenomena such as colliding neutron stars or magnetars to far more speculative explanations, including signals from advanced extraterrestrial civilizations. A recent breakthrough has brought astronomers closer to unraveling the mystery. In a matter of weeks, researchers detected 13 distinct deep space flashes, including the second known repeating burst ever recorded. The discovery was made using the Canadian Hydrogen Intensity Mapping Experiment, better known as CHIME, a state-of-the-art telescope located in the Okanagan Valley of British Columbia. What makes this discovery even more impressive is that CHIME was still in its pre-commissioning phase at the time. Despite not being fully operational, the telescope's advanced design enabled it to capture signals that had eluded scientists for years. CHIME's unique construction gives it capabilities unmatched by other radio telescopes. Thousands of antennas work in tandem, their signals processed by one of the most advanced systems ever built for astronomy. This processing power allows CHIME to scan vast swaths of the sky simultaneously, making it particularly well-suited to detect fleeting events like fast radio bursts. Kendrick Smith of the Perimeter Institute for Theoretical Physics in Ontario explained that CHIME's system reconstructs images of the sky by rapidly processing the incoming radio data. In this way, it can search for rare, transient phenomena across huge regions of space with unprecedented efficiency. Among the bursts recorded was a repeating signal from a source approximately 1.5 billion light-years away. Unlike most fast radio bursts, which are singular flashes that vanish after appearing, this source emitted multiple signals over several weeks. Astronomers recorded half a dozen bursts before the activity quieted. The repeating nature of this source has enormous implications for the study of fast radio bursts. A single, isolated burst could be explained by cataclysmic events like the merger of neutron stars, but a repeating source indicates something more stable and enduring, perhaps a star with unusual magnetic fields or an entirely new type of astrophysical object. The discovery of 13 bursts so quickly after CHIME's activation strongly suggests that fast radio bursts are far more common than previously assumed. For years, their rarity frustrated researchers, but now it seems that our instruments were simply not sensitive or wide-ranging enough to detect them. CHIME's ability to detect multiple bursts so easily shows that the universe may be filled with these strange phenomena, waiting to be catalogued. Adding to the intrigue is the frequency range of the new bursts. Previously, observed fast radio bursts had been recorded at around 1400 MHz. In contrast, CHIME detected bursts between 400 and 800 MHz. This lower frequency range provides scientists with fresh data to examine. It means that these signals are more diverse than thought, and that their sources can generate and transmit energy across a wider range of frequencies. This insight expands the possible models for how fast radio bursts are created and survive the immense distances they travel. Tom Landecker, a member of the CHIME team, highlighted another significant finding. The low-frequency waves of the newly discovered bursts were able to escape their environment and reach Earth without becoming too scattered or absorbed. This means that the environments in which these bursts originate, possibly near powerful stars, black holes, or other exotic objects, still allow for the survival of such signals.